Continuing from last day, you were all here last day, we had a lesson, yes? We're looking at cliffs at angles. That's the physics 12 part, because for cliffs at angles, you need the quadratic formula. Well, you don't. I lied. I like the quadratic formula, Dorothy, because I can do it in my sleep. I can crunch the numbers pretty absent-mindedly, and I know I'm going to get the right answer. It's quick, but I'm a nerd. I'm good at math. I'm wearing my nerd shirt today. There is a second way that you could do this. The second way that you can do this is, instead of finding t first, find v final. Could you find v final from this column right here? You know A, you know VI, you know D. Could you find v final? Is there an equation that has A, VI, D, and VF in it? There is. It's the VF squared equals VI squared plus 2AD. It works. You'll have to remember when you find VY final squared that it's squared. You'll have to square root it. And you'll have to remember one more thing. You're going to get a positive answer on your calculator. Jason, you will have to say, wait. Velocity is not positive because I'm heading down. What's my velocity? Negative. In fact, that VF squared equation, it's a scalar equation because of the squareds. You'll lose any signs along the way. Oh, and then once you have VY final, you can use T equals VF minus VI over A. So it's also possible to get there without it. Example 11 says find the flight time using the quadratic formula. Cliff at an angle. First thing I'm going to do is I'm going to remind myself I'm going to break this up into horizontal and vertical. John, am I at an angle? Yeah. Then, rats. I'm going to have to go components here. I'm not going to use that 35 meters per second. It's never going to appear in the rest of my work. Instead, I'm going to break it up into a horizontal component and a vertical component. And because I like to make really big diagrams, I'll just extend that. I find if I do a small diagram, it's often hard for me to see what trig function I'm supposed to use. I'll call this Vx. I'll call this Vy. John, what do you want to find first, Vx or Vy? Have we done enough of these? Have you spotted the pattern? Vx is going to be which trig function? Have you noticed it yet? You haven't noticed yet that Vy is sine, and there's a dumb way that you can remember that Vy is sine. At least there would be if I was a good teacher. I got nothing, but I'm sure there's some way if you were clever that you could remember that Vy is sine. For what it's worth, if you're doing these cliff questions and you're launching upwards, Vy is going to be 35 sine 20. If you don't believe me, do the trig. Vx is going to be 35 cos 20. Do you have to memorize that? No, you can survive perfectly without it. And in fact, by the end of the year, I've usually forgotten it. It's one of those ones I have memorized during this unit because I'm doing so often, but whatever. Let's bring up my calculator. 35 sine 20, 11.97. 35 cos 20, 32.89. Is that right? Anybody else want to check me? Or am I wrong? I'm right? 32.89. And we've done our horizontal, we've done our vertical. First things I'm going to write here, Chels, AX and AY. Oh, 0. And as long as we're on the Earth, negative 9.8. I think either on the big review package or in your homework, I think there's one question where I put you on the moon. Just use the acceleration on the moon. The question tells you, I think it's 1.66 meters per second squared or something like that. Oh, and I can also say that Vx is 32.89 and Vy is 11.97. Oh, I know one more thing. Vertical displacement. Careful. What is it? Negative 20. Do you guys want to do quadratic formula to find t, or do you want to do the find VF and then use that to find t? I don't care which. You want to do that one? Yeah. Okay. So I don't mind. I did the quadratic formula last day, and those of you that have quadratic solvers, use the quadratic formula, knock yourselves out, or that if you're good at the quadratic formula. But I can choose to then say this. I'd like to find Vy final. Do I have an equation that has a, oh, you know what? I should have put an initial right here, shouldn't I have, to remind myself that it's changing? Do I have an equation that has V final, V initial, A, and D in it? I do. It's this one. V final squared equals V initial squared plus 2AD. We don't use this one that often. Really, though, it shines right now. V final squared is going to be 11.97 squared plus 2 times negative 9.8 times negative 60, Mr. Dewick. Nice try. 20. 11.97 squared plus 2 times negative 9.8 times negative 20. 535. Oh! I found VF squared. What had I better remember to do? What's the answer? I'll give you a hint. It's not 23.14. Ah. Negative 23.14. Gabby, how's that help? Well, now I have 4 things under the vertical column. Now I can find time a lot easier. Is there an equation that has some of those and a t in it? Is there a non-quadratic equation, Jake, that has some of those and a t in it? Yeah. Which one, folks? Can you get the t by itself for me, please? I know you can. It could be argued, Sydney, that if you're quick at this and you're slow at the quadratic formula, then this is the faster method. And I'm all about, Jason, whatever method's faster. I'm pretty quick at the quadratic formula. In fact, I'll be very honest. I can write down the equation, show no work, go straight to my calculator, be confident that I've typed it in right, and just get an answer. I would probably never do that on a test, but I can if I need to. And I respect the quadratic formula. I've done my little speech, I think, about how much I like it. Anyhow, this will work. Negative 23. You know what? I need more room, Mr. Dewick. Let's go like this. Cut. Click. Paste. Haha. Don't you wish you guys could do that? Negative 23.14 minus 11.97, all divided by negative 9.8. What's the time of flight? Let's go to 4 sig figs, because we're going to be using this to calculate a lot of other stuff. 2.582? Sorry? I'm hearing different answers. 3.582. 3.582. Oh, I thought I heard 2. 3.582. Now, they did say in the original question, find time of flight, so I'll give them my answer to 3 sig figs and put a box around it, but and just in case I need to use it for other stuff, I'll keep that on the page. Did anybody use a quadratic solver to solve this already? Who's got the quadratic solvers on the calculator? You guys do? The equation would be this. Negative 60 equals, what was VI? 11.97 t minus 4.9 t squared. The equation would be 4.9 t squared minus 11.97 t minus 60. 60, why 60, Mr. Dewick? Because 60 was the last question. It's 20 is the distance, isn't it? Good gosh. Minus 20. Crunch that in your solver. See if we get a t of 3.582. Just so that we know that this method also works. Do we? Okay. Whichever one you prefer. What can't you do? I like this question. I like this question. I like this question. I like this question. Dorothy, why would I say that? Did you hear me say it was going to be on the test, or are you just kind of the student who notices these things? Okay. What drives me crazy is I see kids do this. When I say find time, they use this right away, but as their V initial, they use 35, and as their V final, they use 11.9. They use a slanty and a vertical, or they do all sorts of weird stuff. On this question, when I say find t, I'd say about 1 in 3 students every year doesn't solve this using the quadratic. By the way, what kind of an equation is this? Quadratic? How do you know? Now, this is a nicer quadratic because the squared that we're trying to get by itself doesn't also have a non-squared term. But no matter what, somewhere along the way, you better be using a quadratic equation. Okay? What's your homework? Part 1. We're going to do a lesson again today, too. Anyways, number 1. Number 2. You know what? Let's do this. Number 1, let's go A and C. 2, let's go A and C. 3, this is the one you need to practice. 5. 7. 11. But let's move on. The next. Lesson 6, projectile motion, part 2. I missed you again? Yeah, I do this every time now, don't I? I don't see you hiding back there. It's a weird place. But you chose to sit there. So, quick review, quick rehash. This is a little summary of what we've done so far on a single page. If you're looking for a good study, kind of a notes page, here it is. We launch an object into the air. We call it a projectile. By the way, projectiles travel in a parabola. Those of you that did pre-calc 11 last year, you've seen parabolas. One of the reasons we study them is not just because they're nerdily delicious and cool. They're projectile motion. As long as you ignore air resistance, projectiles travel in a parabolic arc. But it's easier to use vectors. We break each projectile's component velocity into vertical and horizontal components. So break the following velocity vector into its vertical and horizontal components. Hey, what was the shortcut? What was Vx and what was Vy? Now, do you remember it? There was a dumb way to remember which trig function Vy was. This is going to end up being my original sine the angle. And this is going to end up being my original cos the angle. You can still draw the triangle and do the trig and opposite over hypotenuse and opposite over adjacent and get there too, but okay. Key ideas. Horizontal, Vx is constant. That means that Ax is 0, which means that horizontally for the range, d equals Vit plus a half At squared becomes dx equals Vxt. Oh, this also means if you know the time of flight, you can find the horizontal distance, or the easier questions, Josh, if you know the range, you can find time from this equation. Is this equation a quadratic anymore? No. Much nicer. Much easier. If they tell you the range, Alicia, it's a lot easier. Oh, horizontally, vertically, Vy changes, but Ay is constant, negative 9.8 meters per second squared, as long as you're near the Earth. So this equation is the one you use the most. At the top of its arc, Vy equals 0. That's very handy to remember. Does this mean that your velocity is 0 if Vy is 0? If I throw something at the very, very top of its arc and Vy is 0, does that mean its velocity is 0? Really? Catch, John. Football player, athlete, incoming. You're telling me at the top its velocity was 0?
do it straight up.
It's not what this question says. We're talking about projectiles and parabolic arcs. At the top, is the velocity 0? Only one component. In fact, at the top, I can tell you what the velocity is. It's Vx. It's V cos theta, right? Also, if you start from ground level and end at ground level, no. If we start it from ground level, end at ground level, your initial vertical velocity equals your final vertical velocity. That can be a nice little shortcut too. We said what goes up must come down. Last, if you're beginning from a vertical height, the ground is below you. This means that your final vertical displacement will be negative. We've done from ground to ground already. You know what? I'm going to go, yeah, we've done that. If you want practice, there's the answers. You can try that one if you want to. What I would like you to do is example 2. Example 2 is cliff at an angle. This is physics 12. A projectile is launched from a 45-meter high cliff at an angle of 64 degrees with the horizontal and initial velocity of 36 meters per second. What does DULP stand for? I better draw a little picture. Here's my cliff. Here's my projectile. Yoink. This angle here is 64 degrees, 36 meters per second, and my height is 45 meters. Okay. On your own, break it up, Vx, Vy. Find time of flight, either vertically or horizontally, depending on the information that they gave you. And then find the range, please. I'm going to press pause, and I'll do it up here. I'll freeze my screen. So here's what I'm getting so far. Oh, come on, pen. I chose to find Vy final rather than the quadratic formula because my good graphing calculator is misplaced that has my quadratic solver. So I went this method. And if you're bored and you get this right, try B. Because we're going to be moving on to that next anyways. Who needs more time for A? A couple more? Sure. I did something wrong there, Mr. Duke. What did I do wrong there? VIT plus a half. Ha. Let's get rid of that plus sign. Times AT squared. That seems better. No, I'm still wrong. Or am I? Who needs more time for the range? How many got the range okay? Okay? Zigged? Messed up? Okay, that's all right. B, I started crunching for the height. When I crunched in dy, I got 53.4, but look, the answer says 98.4. Josh? Oh! The math that I just did assumes I'm starting from the ground. I'm not starting from the ground. How high am I when I started launching this thing? 45. So what we actually found out is how high above the cliff it gets, 53.4 meters. But you know what? I'm pretty sure, Shay, I better add that 45 meters. That's the height from the, because we measure height from the ground, not from the cliff. Yes? So I'm running out of room. Plus 45 gives me 98.4 meters, and I'm going to have to go like that. Okay. I'll come back to this if you're copying it down, but let's all of us try C. I like C, I like C, I like C. C is a nice question. At first, C seems really easy because they gave me time. Woohoo! Because that means no quadratic formula stuff. They want me to find the velocity at t equals 2.4 seconds. Okay. What would that look like? Probably something like that. Well, I'm not sure. It could be on its way down. Oh, wait a minute. How long did it take to get to the very, very top? John? So at 2.4 seconds, is it on its way up or is it on its way? So that's a good enough picture. They want me to find this. I don't know this. But I think I know this bottom one here because Vx never changes. What's Vx? 15.78, which I haven't used yet in this question. Well, I did for the range, I guess. 15.78. What's Vy? Now, the most common mistake kids say, oh, Vy is 32.36. No, 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 no. I need Vy after 2.4 seconds because that's the one that's changing. Well, Vy final, I don't know, but I know that t is 2.4. I know Vy initial was 32.36. I know that a is negative 9.8. Can I get the vertical component of the velocity from those things? Yeah? Oh, great. In fact, you know what? I think Taylor, the equation has the Vy by itself already for the change, which is kind of nice. I think Vy is going to be V initial plus AT. It's going to be 32.36 plus negative 9.8 times 2.4. What do you get? How fast is it traveling vertically? It should be pretty small because it's going to come to 0, John, after 3.3 seconds, and we're only 1 second away from that. So I'm going to guess somewhere like in the tens or teens, probably. 8.84. Anybody else? How's that help? How's that help? Really? You're saying that doesn't help? Yes, we can do in fact, we can bring math 8 into the picture here, Pythagoras. So the mystery velocity that they want me to find is going to be 15.78 Let's try that again, Mr. Duke. 15.78 squared plus 8.84 squared, square root. 18.1 meters per second. But actually, Megan, we're wrong. That's the speed. They said the velocity. How do I change this from a speed into a velocity? Velocity is a vector, and all vectors have both what and what? Magnitude and direction. Yeah, we got to get the direction. We got to get angle theta. Dorothy, which trig function? Opposite, adjacent, or hypotenuse? Which trig function? Which one has the O and the A in it? It is. It's what you like to do in the summer. Absolutely. Tan of the mystery angle is opposite over adjacent. Yes? So I'll go second function tan, bracket, opposite over adjacent. 29.3 degrees at 29.3 degrees. North of east? No, that's not north. That's not south. Below or above? Look at the picture. Ah! This one. It's above the horizontal. Above the horizontal. Okay. I don't think I'm going to assign those ones. I think the ones I gave you from the previous assignment are good. We're technically done the unit. Technically. I'm going to spend the next lesson when I see you folks on Monday just looking at the weird questions. On Monday, I'm also going to give you a take-home quiz, which we'll go over on Wednesday. The following Monday is Thanksgiving. I think I see you Friday of next week. Is that right? Could someone look on their agenda? Check for me. Okay, you know what? I'll do your unit test the following Friday. And I'll do a tutorial either that Thursday or that Wednesday after school. I got to look and see if I have a meeting that day. But I'll let you know when we're closer. So right now, I'm planning on the test being Friday, October the 12th, isn't it? October 12th? Yeah? Okay.
So I mean, that's when the ultimate kinematics review is?
That's when the ultimate kinematics review is due. Okay. I'll probably be 2 lessons or 1 lesson into the next unit. The next unit is on forces. The first lesson is a review of F equals ma. I don't think you're going to forget all your kinematics. Oh, gee, if F equals ma, do you think we're finding A fairly often by using D equals VIT plus a ham AT squared and VF equals VI? Yeah, so it's good review anyways. It all flows quite nicely. Okay. So a take-home quiz for you next class. But first, you're going to have the remainder of class to work on the homework from lesson 5, and you can start whittling away at the ultimate review. There's going to be some nasty ones, but you can look online for the solution key. But a couple of videos to show you. Put your pencils down.